Question number 21. Two masses joined by a light string are pulled along a smooth horizontal table as shown in the diagram. What is the tension in the string joining the mass? I will find the resultant acceleration of the system. To the system, we can use F equals ma. When considering the system, there is only one force, it is 20 Newton. Tension is cancelling, equal and opposite forces. Therefore, resultant force is 20. Force 20, mass, we have to consider sum of masses, 4 kilogram plus 6 kilogram, 10 kilogram. Then we can get acceleration is 20 divided by 10, 2 meters per square second. Now we have to find the tension. When finding tension, we can consider only this part, only this object. And we can use F equals ma. Force, tension, there is only one force on this object. Mass 4, acceleration is found as 2. Then 4 into 2, 8 Newton. Answer is 2 for the question number 21. Then 22, two masses m and 4m lying on a smooth table are compressed against a spin as shown in the figure. As the masses are released, the speed of masses Va and Vb are related by. When releasing two objects, there is a constant force. There are two forces on two objects, like this. There are two forces on system, but when considering this part and this part, forces are equal and opposite. Forces are equal in magnitude. Therefore, we can get the momentum of this object, m into Va, should be equal and opposite to the momentum of this object after releasing, 4m into Vb. We can cancel out in term Va equals 4Vb. Then answer is 3 for the question number 22. 23. A golf ball of mass 0.05 kilogram leaves its velocity 70 meters per second. After being struck by golf club, if the time of constant of the ball with the golf club, sorry, time of contact of the ball with golf club is 5 into 10 to the power minus 4. The mean force applied by golf club on the ball. We can get force equals to rate of change of momentum. We have to find the force. Initially, golf ball is at rest, then mu term is 0. Initial velocity 0. Now we can substitute mass of golf ball 0.05, velocity 70. Contact time is given as 5 into 10 to the power minus 4. Now we have to simplify it. 5 divided by 5, 1, 0.01, 70 into 10 to the power minus 2. We have to bring this 10 to the power minus 4 to the numerator, 10 to the power 4. We can cancel out 2 zeros, 10 to the power 3 with minus 2. 7 into 10 to the power 3. Then answer is 3 for the question number 23. Then question number 24. two boys of identical masses are standing on two identical trolleys A and B, which are at rest on a frictionless surface. The boy on trolley A then throws a ball of mass M horizontally with velocity V with respect to the earth. Boy on trolley B. The respective final velocity of trolleys A and B are. For the first situation, I will consider trolley A. Mass capital M and simple A. Ball is in the trolley before throwing the ball. After the throwing the ball is moving with V velocity and the trolley A should move in opposite direction. I will consider velocity of trolley A UA. Then we can use conservation of linear momentum. For this first situation, before throwing the ball, there is no momentum, there is no velocity. Therefore 0. After throwing the ball, mv, it is the momentum of ball, it is in right hand direction, minus capital M UA, it is the momentum of boy and trolley, it is in opposite direction, left hand direction, therefore we have to subtract. Then we can subject UA mv divided by capital M, it is in this direction. Then I will consider trolley B. Before catching the ball, trolley B is at rest. After catching the ball, trolley B should move in this direction with UB velocity because of before catching ball has a velocity V. Then again we can use conservation of linear momentum. Momentum of ball before catching mv, thus there is no momentum for the boy and trolley before catching. After catching, total mass m plus m, velocity ub. Then we can subject ub mv divided by capital M plus simple M. It is in this direction. Now we can get the answer is 3 for the question number 28. Minus mark of first answer is means this velocity is in opposite direction. Then answer is C. 25. The horizontal force of 10 Newton is applied for a period of 10 milliseconds on a body based on a smooth horizontal table. The change in momentum of the body in SI unit will be, we know that product of T, force and time, should be equal to change of momentum. We can get it by using Newton's second law. Force is rate of change of momentum. Then we can get T to this side, Ft equals mv minus mu. Then change of momentum should be equals to Ft product. Now we have to find Ft product. Force 10 Newton, time 10 milliseconds, 10 into 10 to the power minus 3. We have to substitute in SI unit. Answer is 0.1 Newton seconds. 2 for the question number 29. 5. Then question number 26. Two boys A and B standing on horizontal ice surface move apart by pushing each other. The weight of A is twice that of B. A has moved 4 meters. 4 meters. The distance moved by B is. Then considering two boys, there is an equal and opposite force on each other. Therefore, momentum of A, mass of A into velocity of A in this direction should be equal to momentum of B in this direction, mb vb. Now, weight of A is twice that of B. Then we can get weight of A 2m, mass of A 2m, mass of B m. A has moved 4 meters. We know that velocity is distance divided by time. Distance 4 divided by time t. We have to find the distance moved by B. I have considered it as x. Then we can cancel out t and t, m and m. 2 into 4, 8 meters. Then answer is 4 for the question number 26. Then 27. Suppose the time taken for a large airplane to accelerate uniformly from 500 kilometers per hour to 505 kilometers per hour. A car from 50 kilometers per hour to 55 kilometers per hour, and bicycle from 5 kilometers per hour to 10 kilometers per hour are same. Consider the following statements. Part A, all forward with the same acceleration. Yes, we know that time is constant for all three vehicles, all three parts, and change of velocity also constant. Change is 5 kilometers per hour for all three vehicles. Then acceleration is change of velocity divided by time. It is constant for all three vehicles. Then statement A is correct. Statement B, all travels with same distance during the above time period. No, it is incorrect because of distance is depending on velocity. Velocities are different. Change of velocity same, but initial and final velocities are not equal. Then C, the accelerating force on each is same. It's also incorrect. We know that F equals ma. Mass of airplane is a large value. Therefore, required force is a large value to get constant acceleration. Then only A is correct. Answer is 1 for the question number 27. Then 28. Consider the following statements made regarding the action force and the reaction force. They are equal in magnitude. Yes, it is correct. We have studied in theory part. B. They set on the same object. No action and reaction acting on two bodies. B is incorrect. They are opposite in direction to each other. C is correct. Only A and C are true. Then answer is 3. You have to remember that there are 4 properties to action and reaction. First one is equal in magnitude. Second one, opposite direction. Third one, acting on the same action line. Fourth one, acting on two bodies, not the same body. Right, then 29. Figure A shows two blocks of height 100 Newton and not height, it is weight. Weight 100 Newton and 400 Newton, which are connected by light string that passes over a frictionless pulley. Figure B shows the situation when the heavier is pulled down pulled by downward heavier block in the system is removed, and then string is pulled by downward force 400. The respective acceleration of the 100 Newton blocks in two situations are given by. In first situation, there are two objects, 400 Newton, 100 Newton. We can use F equals ma to the system in this direction. F equals ma because of the system is moving to this side. Resultant force is 400 minus 100. It means 300. Total mass 50. We know that 100 Newton weight means 10 kilograms. 40 Newton weight means 40 kilo. 400 Newton means 40 kilograms. Then we have to find the acceleration. We can cancel. Then acceleration for the first situation is 6 meters per square second. We have to substitute values and simplify. For the second situation, there is a force 400 Newton in right hand direction and weight 100 Newton. Now we can use F equals ma to the system. 400 minus 100, 300. Resultant force is 300. But there is only one mass. It is 10 kilograms. 100 Newton means 10 kilograms. We have to find acceleration. I have considered it as a dash. Then a dash is 30 meters per square second. Then we can get 6 and 30. Answer is 5 for the question number 29. Then question number 30. Figure shows the variation of force F exerted by flow on the feet with time when a person jumps vertically upward. The force increase from the value which is equal to the person's normal weight 650 to 1400 Newton in 0.3 seconds. Stays contact for 0.1 seconds. And then drops to zero as feet lost contact with flow. At what speed did the person leave the flow? You have to find the final velocity. Again, force, time. Graph is given in the question. It is like this. This force is 650. It is normal reaction of the man. It is equal to the weight. Therefore, when considering resultant force, we have to consider force difference between final force and initial force. Final force is given as 1430. Therefore, we can get resultant force time product by area of this part. Half into sum of parallel sides. This side is 0.4 and this side is 0.1. Then sum 0.5. Perpendicular distance you have to subtract 0 minus 0, 0. 13 minus 5, 8. Again 13 minus 6, 7. It is the area of this part. It should be equal to MV product. Mass 650, we have to find velocity. Then I will simplify it. 2 divided by 2, 1. 3, 9, 0. 0. 5 into 9, 45. 4 remaining. 5 into 3, 15 plus 4, 19. Divide by 650. Now we can get answer is 3 meters per second. It is the final velocity. Then answer should be 4 for the question number 30.